this is an interesting notion, and this is not a real graph, it's just sort of a conceptual thing that came out of the RCM research. Because RCM is so heavily dependent on condition monitoring, where our emphasis is on inspection rather than on replacement. So the question often arises, how often do we need to inspect something in order to be sure or confident that we will be able to detect a problem before it gets serious? And the RCM researchers came up with this notion of what they call a PF interval. The concept here is that a component starts out in good condition and then over time gradually wears and deteriorates. And at some point the deterioration gets bad enough that we can detect it using whatever test we're using, whatever inspection procedure or measurement procedure or instrumentation we're using to determine condition. And we call the point where we can detect the deterioration to be point P, the point of potential failure. And then if we let the component continue in service, either because we weren't looking, or we weren't looking often enough, or we weren't paying attention, eventually the component will fail, and we'll call that point F. And the question is, how much time is there between point P and point F? In other words, how much lead time does the condition monitoring technique give us before the component fails? And if we can estimate that lead time, for example, just to give you a concrete example, I've done a lot of studies on exhaust valve failures in piston aircraft engines, and in how we can predict exhaust valve failures by doing borescope inspections. And it turns out that the borescope, at least based on the studies I've done, starts to indicate a visible hot spot on an exhaust valve somewhere on the order of 100 hours before the valve actually gets bad enough to fail, where a piece of the valve comes off and the cylinder shuts down. So we would say that the PF interval for borescope inspections of exhaust valves is somewhere on the order of 100 hours. It also turns out that we can usually detect a failing exhaust valve using a digital engine monitor, because as the valve approaches failure, the EGT starts to oscillate noticeably. It's a pretty subtle oscillation, but if you have been trained properly, you can detect it on the engine monitor. And the studies that I've done of that indicate that the engine monitor gives us on the order of 25 hours of advanced notice before the exhaust valve fails. So the PF interval for detecting exhaust valve failures using an engine monitor is only 25 hours. The advantage of the engine monitor is it's watching all the time, whereas borescope inspections we have to schedule. So the question is, if we want to do borescope inspections and prevent exhaust valves from failing, how often do we need to do the inspection? And the basic rule of thumb that the RCM researchers came up with is that if we want to reliably detect potential failures and prevent them from proceeding to full functional failure, we should be inspecting at approximately 1/2 the PF interval. So that says that if I'm right, and the borescope gives you about 100 hours of lead time before an exhaust valve fails, then we really ought to be inspecting with a borescope every 50 hours if we wanted to completely eliminate the possibility of exhaust valve failures, which would basically be doing a borescope inspection every time we do an oil change. Now, very few people do that. Most people are lucky if they get a borescope inspection at an annual, And a lot of shops don't do them at all. If you do a borescope inspection just once a year, and you're only flying 75 hours a year, that might be enough. If you're flying 300 hours a year and you only do a borescope inspection once a year, that's not enough to assure that you will catch exhaust valve failure before it happens. So that's the notion of the PF interval.